This was a very interesting session with many different tumor types. We discussed tumors that were highly sensitive to current immunotherapies, but also a tumor type that was highly insensitive to immunotherapy. For instance, ovarian cancer. And there you can see that despite the fact that immunotherapy is already around for 10 years, hardly any progress has been made. So some of these cancers are highly resistant to immunotherapy. The same may be true for prostate cancer, although, slowly but surely there are there's progress coming. And this progress is coming because we are now seeing possibilities of treating patients not only with the immune checkpoint inhibitors that let's say, activate the immune system, but also using what we call adoptive cell therapies, where we use, for instance, chimeric antigen receptor T cells or other cell therapies that can work against these cancers that do not respond to what we call immune checkpoint inhibition. Of course, there's also tumor types that are highly responsive. And there we see that these cancers benefit more because the new treatments that are emerging oftentimes combine the old treatments, and with old I mean the currently available immunotherapies, with new ones. And these new ones can be different types, right? It can be other checkpoint inhibitors targeting new molecules. It can also be combination of the old molecules, the other checkpoint inhibitors, with what we call local therapies, where we inject sometimes viruses, sometimes other immune activators in the tumor in order to change the local, what we call tumor environment, to make the cancers more susceptible to the older immune checkpoint inhibitors. So I think what we're seeing is that we need to try to understand better why some tumors respond very well, whereas others do not. And currently we have so many possibilities to analyze, to dive deep into these tumors with technologies that allow us to really dissect on a cellular level the differences between responding and non-responding patients. And by using this complex multimodality analysis, we hope to unravel the mechanisms of resistance and hopefully also to find new targets that we can then try to use to improve the current treatment options.